WAN Technologies Lab, configuring PPP authentication. In the last nugget, we went through and did the base configuration of PPP. That is, we have IP addressing configured, static routing enabled, and PPP encapsulation, which is the key, enabled between the Lilo and Stitch routers. Now we're going to dive into the authentication components. You remember the 4 different realms of PPP features: authentication, multi-link, callback, and compression. Those are things you should be able to call off the top of your head. Those are features that you can enable, and within the authentication bucket, you have 2 different forms: PAP, or the Password Authentication Protocol, which is clear text, and CHAP, the Challenge Handshake Authentication Protocol, which is hashed authentication. I'm going to explain what that means as we do this. It's actually really cool. So the first thing we're going to do is enable PAP authentication between Lilo and Stitch, and then use the appropriate debug commands to prove authentication is occurring. This is going to be fun. I read these objectives, I'm like, ooh, this will be cool. All right, so here's the basics of what we're going to be doing. We need to authenticate Lilo to Stitch and Stitch to Lilo to make sure they're authorized to connect over that WAN connection. There's really 3-ish major steps that we're going to do. The first is to create the account. And it's exactly what it sounds like. It's a username and password. So when Stitch comes over to Lilo and says, "Hi, I want to connect over this WAN link," Lilo can say, "Okay, well, let me check you against my user database. You said you're Stitch, right? And then let me check your password you're giving me. Okay, check, you're good. I'm allowing you in." The second step is to assign the credentials. That is, when Stitch comes over to Lilo and Lilo comes over to Stitch, they have to know what to say to each other. Stitch has to say, "Hey, my name is Stitch, my password is this," right? Those are the credentials that we assign, and they're assigned on a per interface basis. The last step is to enable PAP. This turns on the authentication components. Well, there are our Lilo and Stitch routers sharing coffee over a lonely WAN link in the middle of the desert. So let's hop on over to the Lilo router first and get them set up for PAP authentication. First step, create a user account. Done from global configuration mode, and this will be a user account for the other side. So Stitch will come to Lilo and say, "Hi, my name is," and we can configure that, but I would say for now, Stitch, and my password is this. And so Lilo has to have something to authenticate them against. So this is how we do it. Username, and you type in whatever Stitch is going to use. I'll just say Stitch. Now, careful, that is case sensitive. So if I use a capital S there, I have to use it on the other side. I'll then say, and hit the question mark, you can see there's all kinds of things you can attach to a user account. You can say, "I want to have automatic commands run when this user logs in," because these could be user accounts that authenticate to your router as well, right? To manage it, administration, etc. I could say there's no password on here. There's a one-time password. I can type in the password, and that's what I'm going to do right now. Or I could type in the secret. And this works the same way as the enable password and enable secret protects the privilege mode. This one will be stored in the running config in clear text. This one will be stored in the running config in a hashed form. We might as well use secret, even though PAP is a completely clear text protocol. So it will send these credentials over the WAN link in clear text. I'll show you that in a second too. So I'll say username Stitch, secret, and I'll hit the question mark. What's the password for the other side? Let's just say Ninja. It just popped into my head. So now I've created the user account. Second step, I want to assign the credentials. So Lilo now has the user account that Stitch will use when it authenticates. But now I need to say, well, Lilo, I want you to authenticate to Stitch with this. Those credentials are configured from the interface configuration mode. These guys are connected on serial 1/0. So I'll get under there and I'll type in PPP PAP, and I'll hit the question mark. Sent username is the command that we're going to type in there, saying to Lilo, this will be what you send to the other side. This will be what you send to Stitch. So we might as well say, well, you'll be Lilo on the other side. Now, of course, on Stitch, we're going to have to create the Lilo account, right? You know where that's going. Hit the question mark. It says, okay, what password are you going to use when you're talking to Stitch? I'll say, well, the password will be fuzzy. These are things that just pop in my head. So that's now the credentials that Lilo will use when authenticating to Stitch. Now, what I'm going to do is I'm going to turn on PAP authentication, and we're going to see this thing go down, right? The way you turn it on, this is step 3, and you'd usually do this last once you have both sides configured. PPP authentication, and here's your different modes. I'm going to say PAP. I'm so used to the copy and paste of putty. So I'm going to say PAP. There we go. So we're now enabling authentication on that link. And what happens? the link goes down. Why? Because the other side is not configured for authentication. We've required it. It's not happening. PPP terminates the link. I'm going to drop back into a show interface serial 1/0. Let's just take a look at that. If I could do that, it says right now, encapsulation PPP LCP listen, meaning right now it's in the middle of trying to negotiate with the other side. It's not going to happen. You can see that the line protocol is still remaining down. If I wanted to see it, I could type in debug PPP authentication. You can see right there at the top, and it will actually show me as authentication is happening. And it's saying, hey, right now, authentication is required. It's not happening. I'm getting no answer from the other side. So I'll do a UAll and turn that off. Let's go fix it. I'm going to head over to the Stitch router. Shoot. All he sees is his serial interface is down. So let's go in and fix that. Create the user account. Username, we'll do Lilo, and the secret, we'll put it in there as, is fuzzy. That creates the user account for Lilo to authenticate as he comes in. Now I'm going to go under interface serial 1/0, and you can, again, type these commands whatever order you want. I'll do PPP authentication PAP and enable PAP authentication. And then let's add the username that Stitch is going to send to the other side. I'll type in PPP PAP sent username. So I'm going to say this username that Stitch is going to send Lilo will be Stitch, and it doesn't have to be. I'm just using it as that. It could be G.I. Joe. It could be anything that you want, as long as you create the according user account on the other side. So send username will be Stitch. The password that we'll send to the other side is Ninja. And hit the enter key. And I'm waiting. Boom. Right there. The line protocol has changed to up because it's now negotiated with the other side, that authentication, and I see the WAN link is online. Cool. So last thing I want to show you is I want to show you how it happens and how it looks if it's broken. Right? So that way you can recognize this. So let's do this. I'm going to go under interface serial 1/0, and we'll do no sent username Stitch, and we'll do a PPP PAP username sent username Ninja 1, right? So it doesn't match the other side. Now it's already authenticated, so the link is staying online, so it's not going to continue to ask for authentication. So let's do a debug PPP authentication. And let's also take a look at the negotiation, so we can actually watch the negotiation happen. Do a show debug. Little command not many people know exists, so it shows you what debugs are actually running. Okay, cool, so I see that. Now let's go under serial 1/0, and we'll do a shutdown. Turn the interface off. Notice LCP steps onto the scene, closing the connection down. You see the two network control protocols, IPCP and CDPCP, closing down. So kind of fun to see that. Now I'm going to do a no shutdown, and let's watch the fireworks display. Physically, line comes up. It says, okay. It says a lot of stuff. So you can see right here going across the connection. Actually, this is just going to keep on going because it's going to keep trying to authenticate and fail and fail and fail. So hang on, we'll do a control. Oh, I can't stop it. Let's see if I can freeze the screen. There we go. Okay, so take a look right here. We've got the authentication required coming in. It's saying from Stitch, from Lilo. So this is two-way authentication. It says, okay, we've got a unauthenticated user. We're requesting the login, requesting the password, and then down here, notice, bam, authentication failed. And then it just keeps on looping. If I unfreeze the screen again, you can see it just keeps on going and going and going and going and going because it's continuing to try and authenticate and failing. So I'm kind of doomed because I can't even get a prompt back. It's scrolling too fast from my console port. So I'm going to head over to Lilo and actually interface 01/0 and shut the connection down because I know eventually that will stop that debug on the other side. And now we just wait. There we go. Got my prompt back. So I'm going to do a UAll. That's why debugs can be dangerous. I'm going to go into the interface 01/0, hit the up arrow a couple times, and fix that. No. And there. Last thing I want to show you. Bailout right here. Let's, actually, I'm going to close this guy. File, quit. Yes. And let's bring up a Wireshark of this connection. I'm going to start a capture on the link between Lilo and Stitch. And this time, instead of choosing HDLC, I'm going to choose PPP, and we'll do it from Lilo's perspective. Click on OK. Wireshark will start up. Good. We've got a capture running in the background, which we'll see no packets right now because the link is shut down. So I fixed the username. Let's go over to Lilo and do a no shutdown, which should bring up that connection. And we should see some traffic going across in Wireshark. So take a look at this. We've got PPP. Notice it's identifying what's doing the negotiation. It's saying, hey, there's a configuration request right here. We can even open it up inside of Wireshark and say, okay, it's asking for the password authentication protocol. It's got some magic numbers put inside of there. And without diving too deep into the authentication, this is somewhat of a check to make sure that there's not a man in the middle injecting stuff in the middle. So we've got some configuration requests. Now look at this. This is the key. I mean, Wireshark doesn't even make you dig for it. It's like authentication requests. Oh, by the way, he's saying my peer is Stitch and my password is Ninja. Why? Because it's just straight up plain text right here. Stitch and Ninja is going right across that wire. That's the problem with PAP, is everything is clear text. So if anybody, now the good thing is this is a point-to-point WAN link, but if somehow anyone was in the middle, it's so easy to compromise that stuff. And that's where CHAP authentication comes in. See, PAP is great and all, but hardly anybody uses it anymore because it's clear text, and CHAP is just as easy to set up. So why not use a hashed version of authentication instead of clear text? Now, you notice I said hashed and not encrypted. And that's because it doesn't encrypt anything, but it is very secure the way it uses it because it uses MD5 hashing. Here's a big, broad picture perspective of how MD5 hashing works. When you set up your user accounts, so same process, right? Set up your user accounts. I'm going to say I'm going to create one for Stitch, and the password is 123, right? This guy's like, I'm going to create a user account for Lilo, and the password is 123. Now, here's a requirement of authentication with CHAP, is the passwords have to be the same on both sides. It's not like the PAP example we just saw where we had one side being a Ninja and the other side being fuzzy. That's two different passwords. In this case, we have to have the same password, and it is a two-way authentication. So when the PPP link comes up, Lilo sends a message over to Stitch saying, hey, let's bring this thing online. Stitch is like, all right, well, that's cool, but I want to make sure you are who you say you are. So it sends a message over there. If we were to break open that message and look inside, he would say, my name is Stitch. And this is his username that he's using to authenticate. And I'm going to throw a little identifier so we can remember which session this is, because maybe Stitch is authenticating multiple people at the same time. You remember PPP was designed for dial-up modems back in the day when you had banks of modems and AOL was the only internet service provider people used, right? Those are the days. So Stitch, you have this ID that identifies the session and then just some random number that Stitch makes up. This stuff comes over to Lilo and he's like, oh, I see how it is. You want to do a little CHAP authentication. Well, okay, I'm going to take all of these things. I'll first off take Stitch and look it up, and it looks like the password for Stitch is 123. So I'm going to take that, 123. I'm going to take the ID right here. I'm going to take the random number that you sent me, and I'm going to put it into this meat grinder called MD5, and that's really what it is. MD5 is just a mathematical meat grinder where you can put anything in it, and it spits out some fairly long value. Now, the fun part about this mathematical meat grinder is if even one thing changes, one bit of information changes in any of these values right here, the answer comes out completely different. And it's an irreversible mathematical formula. Now, I know some of you out there are like, foolishness, I can reverse anything mathematical. No, you can't. Because if you could, then the world's security would fall apart and people would be freaking out. The internet's falling, secure banking, everything would be dying because there is so much that relies on some mathematical formulas being irreversible. So when you put all this stuff into the meat grinder and it spits out this, that is known as the hash. The reason that I emphasize that it's important that it is an irreversible answer, like you can't see that answer and be like, okay, well, it's not like, x plus 5 equals 52 and you're like, oh, sweet, I just got x right there so I can, do a little subtract 5 action and figure out what the answer is. No, that's not how it works. You can't reverse that because it sends that back to the Stitch router. Stitch was saying, hey, give me a little CHAP authentication. Lilo's like, I got your CHAP authentication. I'll put this together and put this hash value back. So the answer that it sends back, he says, hey, I'm the Lilo router, and I'm going to give you this hash. So the Stitch router goes, Lilo, I see. I see that you have the password of 123. So let me see. I'll take 123. I'll take the ID that we both put in that little packet, right? The ID and that random number that I sent you. And I'll put it in my MD5 meat grinder. And it goes, looks like the hash is the same. That means that we have the same password on either side. That means you're authenticated. What I just showed you there is one-way CHAP authentication, because Lilo would then pull the same move on Stitch and say, why don't you send me some hashed information so I can make sure that you are the way you are? And that's what we call two-way CHAP authentication. So the end result is we never actually send the password over the wire. We only send a hash value, which is the password combined with some ID and some random number put into a meat grinder and ground all up. So you could argue, well, isn't that encryption? No, it's not really encryption. It's hashing. The beauty of hashing is it's quick, easy, and painless for your router's processor to do. So now let's do the CHAP configuration. Behind the scenes, I went in and removed all of the PAP stuff because you have to choose one or the other, CHAP or PAP. So all of the CHAP stuff, the sent username, the user accounts, I've deleted all of it out of there. Let's start off on the Lilo router. Hit the enter key. Global config mode, username, Stitch, password, and let's just do 12345. Right? I'm recreating that user account with the password 12345. Then I'm going to go into interface serial 1/0. Do PPP authentication CHAP. I don't need the sent username and sent password, anything like that, because it does that two-way authentication automatically. So I'm going to head over to the Stitch router, and let's go into global config mode, interface serial 1/0, and we'll do, hang on, username, Lilo, password, 12345. That has to be the same. If that's not the same, the two-way CHAP authentication will fail. So I'm going to go into interface serial 1/0, PPP authentication CHAP. Done. Right? So let's watch it happen. I'm going to do a debug PPP authentication, and that should be enough for us to see. We'll go into interface serial 1/0. We'll do a shutdown. Terminate that link and then do a no shutdown to see if we can watch the negotiation happen. There we go. It was that fast. It came up and said, interface has been changed to up. I'm using the connection as dedicated line. It says, okay, challenge from Stitch, challenge from Lilo. So it did what I just showed you. They both of them sent challenge at the same direction to each other, I should say, at the same time. So this is the two-way authentication. Response comes back that contains all the hashed information. He's responding saying, okay, I'm using the username from an unknown source, meaning Lilo has sent me his username. I'm going to use that. I'm going to process that with AAA authentication, authorization, and accounting. You'll learn more of that as you dive into CCNP stuff. And as you fly down the rest of this, you see that the end result is we have two different success messages. That's the two-way. One sent, one received between the two sides. And then right after that, boom, line protocol changed to up. That is the simple and secure magic of PPP CHAP authentication. The last step of this lab will be enabling multi-link, which we'll do in the upcoming nugget. For now, I hope this has been informative for you, and I'd like to thank you for viewing.